Dr. Ann Weiss is the NASA STEM Engagement and Educator Professional Development Collaborative, EPDC specialist at Langley Research Center in Hampton, Virginia. In a quest to fulfill a lifelong dream of flying in space, Ann originally trained as a neuroscientist, including research work at the U.S. Department of Energy's Los Alamos National Laboratory in New Mexico. For the past 20 plus years, Ann has merged her scientific training with her passion for education as a middle school, high school, and undergraduate science educator. Since 2010, Ann has contributed to a variety of NASA STEM engagement projects, including the NASA Educators Online Network, NEON, the Aerospace Education Services Project, AESP, excuse me, and the NASA Community College Aerospace Scholars Program. So thank you. Welcome, Ann.
All right. Well, thank you. I greatly appreciate this opportunity. I want to thank the SEEK board and the faculty of the College of the Canyons for this opportunity to share some of the amazing things that we do under our Explore Earth communication theme here at NASA. Hopefully you see on the screen my cover slide. If someone could let me know.
Looks
yes,
good.
no. Okay, all right. So what I want to do first is I want to kind of share a little bit additional information about my background. I knew what I wanted to be when I was 6 years old. I grew up in a family where my father was a pilot. And so from the time that I can remember, it was airplanes, airplanes, airplanes. And so for the longest time, I thought that was what I was going to do until April 12th, 1981, which was the launch of the Space Shuttle Columbia. And I can't describe to you, but something clicked and it was like, I want to do that. Even though there were no female astronauts at that point, there were astronaut candidates that were training, but there had been no females that had gone into space. Now, my parents thought for the longest time that this was just a passing fancy, and slowly it dawned on them that I wasn't going to let go of this dream. And so I figured the best way to get a spot on the space shuttle was to become a research scientist. I began as a space science major. That's an interdisciplinary major that involves physics, astronomy, and engineering. About 2 years in, I discovered that my passion for biology outweighed my passion for physics and math, and so I changed majors. The other thing that I wanted to sort of point out in terms of on my way to achieving my dream is the incredible role of the teachers that I had the fortune of coming across, because I also had a learning disability. I had something called auditory dyslexia. There wasn't even a name for it until I was a junior in college. And I have to thank my teachers, but I also have to thank my mom, who the picture on the bottom row with the thumbs up, that's mom. She sat on the couch with me every single night when I was in grade school to make sure that I kind of overcame whatever this was that we didn't know what it was until I was in college. And so for a great number of us, where we are today is thanks to mentors and teachers. And so I want to give a shout out. In fact, that's part of the reason why I am an educator, is because I want to give back the incredible gifts that were given to me. And so I just want to say, in terms of a piece of advice, is to the students, whatever it is that you're passionate about, you can make that your career. You can make that your job. And I think for all of the panelists, I think we could all say that it's not a job that we're doing, it's our passion. I get up every morning pinching myself that I get to do the types of things that I get to do. And it's not really work to me. And so with that, I want to transition into what do we do at NASA. I'm going to talk a little bit about our work using our satellites in terms of assessing the environmental impacts of the COVID-19 pandemic. Because of my scientific training and then also my education, my position allows me to basically merge those two things. And if you had asked me, even in college, whether I could be sort of an education sort of science ambassador for NASA, I would have shook my head and said, no, that's not possible. So when I was in college, I didn't realize that the position that I'm in now even existed. So ever since we were formally started in 1958, in fact, we just celebrated our birthday just a couple of days ago, we have been watching the Earth. We have been putting satellites into orbit. Some of them were communications, but a lot of them were weather satellites and just scientific satellites that allowed us to look back on our home planet from the vantage point of space for the first time. And so ever since, we have basically created this system where we've take essentially the vital signs. Think of like a doctor taking blood pressure or your heart rate. That's basically what we do here at NASA with our satellites. We're taking the vital signs. What's the temperature of the oceans? What's going on with the clouds in the atmosphere? For a little bit more, I'd like to go ahead and show, in fact, I guess I need to get out of my screen share. And I'd like to have to show you a video that kind of gives you an overview of what these satellites do.
The third rock, the blue marble, Earth, home. Every person, place, or thing we know, everything we do, every memory we make, it's here on this pale blue dot. It's just one rocky planet in one solar system in one galaxy among billions. Even as we explore space, we study our home planet. We see it like no one else. An expansive ecosystem. The vegetation, the air, the water, the ice. Our data improves the way we grow food and how we manage the land we cultivate. NASA has over 20 satellites, measuring the height of oceans and inland waters, clouds and precipitation, carbon dioxide, and much more. For decades, our data has tracked how all these Earth systems interact. From above, we see the connections. Cities transition into farmlands. Tributaries flow into rivers, into the sea. Winds move clouds around the planet. Beyond these observations, NASA's ability to model and anticipate how the planet is changing helps communities around the world prepare. We see our changing planet, hurricanes, volcanoes, fires, and we see the impacts of humans, melting ice, rising temperatures. Earth's climate has changed and is still changing. Our data gives us the understanding to adapt and to protect our home planet in new ways. Our electric flight technologies will reduce fuel and save energy. We will make cleaner air travel possible. By understanding our changing world, we improve lives and safeguard our future. The future of our little rock in the universe, our Earth, our home.
Let's say thank you for showing that video. Let me go back in. So now you should see a picture of the Himalayas. So we go back to the beginning of 2020. NASA has been taking data from the Earth for a number of decades. No one could have predicted what was going to happen when the first news stories started breaking of this virus that was starting to create these havoc all around the world. And of course, we didn't really know much about the virus. We didn't really know much about how to contain it. And so all around the world, various countries started instituting various forms of partial or full lockdowns. And very quickly after those lockdowns went into effect, people started sharing anecdotal stories on social media about things that were occurring as a result of the lockdown. And one of the most famous ones happened in India, in the Jandhar district, where folks who knew that the Himalayas were, within 150 miles of where they were, had never seen it because the smog had been so bad. There were people in their lifetime who had never seen. And because of the lockdown, because people couldn't travel, the smog cleared. And so people were reporting, oh my gosh, we can see the Himalayas for the first time in 30 years. And so this very quickly caught the attention of scientists all around the world. What is the impact of these lockdowns, of people staying home, not being able to travel, we not be able to live in the type of society and world that we were right up until March of 2020. And so what I have here on the screen is a dashboard that the general public can access. There's actually a couple of them. NASA has a dedicated one, but the one that I want to share with you is the one which we partner with the European Space Agency, ESA, and the Japanese Space Agency, JAXA. And what this does is it allows anyone around the world to access the satellite imagery, not only from NASA's satellites, but also ESA's and JAXA's, to basically see sort of a before and after, to access the data before the lockdowns imposed versus after the lockdowns. And you can go to pretty much anywhere in the world and you can access a variety of data and see what kind of differences are there in the satellite data in your location between before the lockdown possibly and certainly after lockdown. And I don't have the time to actually walk you through the tutorial, so there is a link there to a video on YouTube that actually gives you an orientation of how to use that particular dashboard. But what I want to do really quickly is kind of share with you how we sort of pivoted. We have this amazing opportunity that gives us this situation to take a look at research questions in a rapid fire way. And so this is two projects I'm going to show you are part of what's called the Rapid Response and Novel Research in Earth Science program. It's part of NASA's Earth Science Division Research and Analysis, Applied Sciences program, and Earth Science Data Systems program. And basically the goal is to redirect NASA's existing data products, things that we already were creating from these satellites, towards understanding the environmental, economic, and/or societal impacts of the global COVID-19 pandemic. And so the primary data sources are the NASA data and imagery, but they are also being supplemented with remote sensing data products from government agencies, international, or even commercial sources. And what the goal is to make quantitative, that's numerical, connections between changes in social or economic activity as a result of the pandemic lockdowns and resulting Earth system environmental responses. This program includes a total of 17 programs. These are currently ongoing, so I can't necessarily provide you data, but I can at least give you overviews. So the two that I'm going to share, the first one is wildlife management. And the reason that this project was funded was because there are obviously environmental impacts from wildfires, and in two different situations, there's two different outcomes. First one, here in the Southeast, we typically do prescribed burns, but because of the pandemic, people who work for the U.S. Forest Service who traditionally do those prescribed burns could not travel. Conversely, out west with the firefighters, you could not have large camps of firefighters because of social distancing. And so this particular question is using data from the Xiaomi NPP satellite to basically understand, were those sorts of things have an impact on the net increase or decrease of pollutants by not being able to do those prescribed burns, for example, or by not having the firefighters in this densely populated response crew as we normally would, does that have an impact on fighting the fires? The other project deals with the oceans. There's plenty of places around the world that depend on tourism, and that has impacts on the marine natural resources. So because people couldn't travel, what is the impacts? Is that going to help the coral reefs? Is that going to help the fish populations, etc.? If you remove those sorts of pollutants, nitrogen, phosphorus, things that might be exhausted from the tour boats and stuff like that. Once again, that's also going to be using data. This time it's involving the Terra and Aqua satellites, as well as the Xiaomi, and basically compare before and after. And so just really quickly, of course, the environmental impacts of COVID-19 are not the only things that NASA is looking at. This gives you sort of an overview of some of the other projects. The STEREO, the Scalable Traffic Management for Emergency Response Operations, is trying to help and improve the efficiency of response to wildfires, hurricanes, and other natural disasters. Detecting earthquakes from air. Can we come up with alternative means of measuring earthquakes than just ground-based stations? Taking a look at river deltas and how creating land or losing land and sea level rise are impacting river deltas and the incredibly biodiverse ecosystems that you find there. How can we maintain marine resources, aquaculture, in a sustainable way? And of course, sustainable green aviation. How can we fly in a more environmentally friendly way? Because here at NASA, we do use airborne platforms to do research. If there's anything in there that I've talked about that has piqued your interest, I want to leave you with this particular slide. Feel free to email me. We love emails here in the Office of STEM Engagement from students. We do offer internships, paid internships and fellowships. So intern.nasa.gov will get you started. For the community college students, this is a program that is near and dear to my heart. I helped bring this to Langley Research Center a couple of years ago. It is a nationwide program. It's run 3 times a year, fall, spring, and summer sessions. You have an online component, and then for those students who score well enough, they have the opportunity usually to come to a NASA center to interact with NASA research scientists and conduct a robotics competition, design a robotic rover for next mission to Mars. For California, there are additional programs. Every state in the nation has a space grant, so I direct you to the California Space Grant Consortium there for additional resources and programs that are in your program, including funding that can support undergraduate and graduate research in STEM areas at the colleges and community colleges there in California. And so with that brings me to the end of my program. Thank you very much again for the opportunity to share that with you.